Notes up for today. Today we are looking at notes for 3-5. I don't know why I wrote 3-4 up here. We're looking at notes for 3-5, and we're going to be looking at triangle angle sum theorem, exterior angle of polygon, remote interiors, triangle exterior angle theorem. Those are the things we're looking at. Big dogs. Okay. Basically, we're coming down to the total interior angle value of a triangle is 180. We're going to talk about the remote exteriors, or the remote interior angles equaling the exterior angle, okay, when we add them together. So we're going to specifically define what those are, and the reason we're doing that is supposed to make you more efficient as you're going through and doing problems. Okay, so today's objective, to use parallel lines to prove a theorem about triangles. Okay, we'll do that, and define measures of angles of a triangle. So as I go through today, we're going to talk about this parallel postulate first. Okay, through a point not on a line, there is one and only one line parallel to that given line. Okay, if the point's not there, there's millions and billions of points, an infinite amount of, I shouldn't say points, but lines that can go through that point. Okay, but the problem is only one of those lines is parallel to the given line provided here on my sheet. Take triangle angle sum theorem. Okay, theorem 310. The sum of the measures of the angles interiors of a triangle is 180 degrees. Okay, so I'm talking about the inside value. If I add up A, if I add up B and C all together, in every triangle, it sums to 180 degrees, always. Okay, which is kind of convenient, but we need to kind of look at this as a proof, okay, because that was one of today's outcomes. Okay, so we have a proof of triangle sum theorem. Given triangle ABC, line PR is parallel to line segment AC. Now, a couple things I want to go over on this. Angle 1 and angle A are alternate interiors in this particular setup. Angle 3 and angle C are also alternate interiors. Okay, so we know that they're congruent already, and later I'll be able to substitute those. The next piece of information I need to work with is what's going on with angles 1 and 2 and the breakdown of it, because I want to be able to show what's happening here. So as we go through, I want you to know that I've got to start with my given. And I got angle PBC and angle 3 are supplementary. Well, PBC and 3 are supplementary. They are a linear pair. Okay, and if they're part of a linear pair, the two angles are supplementary. So that's that linear pair postulate. And because of some information from chapter 1, and we've been using this, angle addition postulate. Two angles can add to be a larger angle, so long as they share a common vertex and ray. Well, I have shown the common vertex and ray, BC, common vertex is B, ray is BC, and the angle PBC and the angle 3 are 180 degrees. Now, excuse me, I backed that up. I was confusing two other things. Let's talk about the fact that PBC plus measure of angle 3 are 180 because of definition of supplementary angles. I was thinking about PBC and angle 1 and angle 2, so I apologize for that. But angle 1 and 2 create PBC. And the reason we're doing this is that I'm showing you that not only do two angles add together to be 180, but I can have three. I'm going to substitute them in. So I'm looking at angle 1, angle 2, and angle 3, all being 180. Now, some people are like, why didn't you do that in the first place? Well, because right now, we only know that two angles can be added to be 180, and I did that, supplementary. And then I substituted based on angle addition postulate the other two pieces of PBC, so I've broken that down. And why? Is because a triangle has three angles, okay? And we're proving that the three angles of a triangle will add to 180. So now we know that straight angle is 180. We know these two by substitution. And now let's talk about those two angles I pointed out the first part of our proof of alternate interior angles. Okay, so we've got those going on, with 1 being congruent to A and 3 being congruent to C because of alternate interior angles. Okay, now here's the big deal on this. I can't add, subtract, multiply, or divide anything that's in congruence, or substitute for that matter. I need to get it to equality. In order for me to do that, I must make sure I go from congruence here, okay, I've got congruence here, to equality here, and that should be angle 1. I'm not sure where I came from, but angle 1. So I've got angle 1 and A are equal now, and angle 3 and C are equal because of the definition of congruence. I do this step, so now I can use substitution. So I go back up to step 5. I'm using step 5's result there, and I'm going to substitute where I see 1, angle A, where I see 3, angle C. And I'm able to do that by substitution, and that's what I was supposed to prove at the beginning. Be talking about the connection between those angles in that triangle, A and C, with 1 and 3. Okay? Now, that's objective 1, seeing a proof about triangle sum theorem. Objective 2, properties of triangles and their sum. Okay, so as we go, here's the deal. Let's see what you know. I got finding the missing angle measures. Okay, 70 plus 35 plus x will be 180. Because of triangle sum theorem. So I got 70 plus 35 plus x is 180. Go ahead and find x by combining like terms and solving. Okay, you guys got set up there. Let's go after it. So we got 110, or 105 I should say. 110. We got 105 plus y, excuse me, x, is equal to 180, so 75 is my x as we go through. Now, a shortcut to this setup, when you have a right triangle and you are looking for one of the 2 acute angles, if you have a right triangle and you're looking for one of the 2 acute angles, what you're really looking at is the idea of that 60 plus x is 90. Okay, because really 180 minus 90 is 90, so I'm just kind of taking that out because these 2 together must be 90, okay, in a right triangle. So now I get that x is 30, and we'll pull that out, okay? Questions about A or B? You guys are on, you got C and D. Go ahead. Remember, the theme is all 3 interior angles of a triangle will add up to 180 degrees. If I have 2 angles that are the same measure, I just represent it as 2x plus 50 in C and set them equal to 180 and solve. Now we got this going on, right? How'd you do? Had some great work going on the side. Are there any questions on how I got to 65? No? We're good? Doing all right? I would like you to do D. And I always have folks go, I was like, well, you know, that's 3x equal 180. Now what? I said, what's 18 divided by 3? And they go, well, 6. Put a 0 on it. 60. All right, great. You're done. Okay, now a couple little extras about this. Anytime you have 3 angles of a triangle that are the same, you have something called equiangular triangle. Okay, it's an equiangular triangle. Equiangular and equilateral are synonymous. They're almost the same thing. Because if you have all 3 sides the same, equilateral, you have all 3 angles the same. Okay, equiangular. So keep that in mind as you're solving. This will come back. I always have students come up to me and go, Bloom, you didn't give us enough information. I went, student, yes, I did. I did? You did? Yeah. 3x equals 180. So now here's the deal. I want you to use your problem solving caps, put them on, Find the values of E. You have been given examples of each, and find the stuff for F because you've been given examples of each. Go ahead. Okay, E. We got X is 70, we have Y is 40, and we also have Z is 40. Now, remember, we're doing total interior angle value of a triangle is 180 degrees. The first place you should probably started right here. They're a linear pair. Okay, X and 110, X has got to be 70 because they make 180 degrees. Now, because X is 70, so is the other X because they're the same variable. Okay, so now I've got 70 and 70, 70 and 70 plus Y, and that's what I got down here. 70 and 70 plus Y is 180, so that's where I get Y is 40. Are you okay with my X and my Y so far? Feeling comfortable with them? Now, keep in mind, I have 30 plus 110, so now I'm on here. 30 plus 110 plus Z is 180, and that actually would be 140, and again, Z is 40, and that's what's going on. That's just because I felt like it. Remember, all my relationships are based on the information that's been provided. Get after F if you haven't already. Some people are done, some people aren't. See what you can do. Talk to your row partners if you're stuck, because right now you're right on the fence. Okay, but I'm going to let you in on a secret. X plus X plus X is 180. Did we do that one earlier? And we have that's an equilateral triangle, and then we also have one that's isosceles. That's where that Z comes in. Z, and Y. And then Y and that other X are supplementary. Those are my hints I'll give you. Go for it. Archie, that's a question you should never ask open-ended like that. Future reference. When you set yourself up like a volleyball like that, someone's going to spike it. No, he answered in the negative just to annoy you. Okay, this is what we got. Hopefully you're seeing it. I got X is 60 because 3X equals 180. Now, X is 60. 60 plus Y is 180, so Y's got to be 120. That's where I got X and Y. I got them going on. But remember, now that Y is 120 and my two Z's, 120 plus the two Z's, but those two Z's got to be 60 with each other. There's a couple ways I'm looking at it. Z's 30, and I could use that this is 30, or I could use that 30 plus 120, Z, got that, Z is 30, but noticing that Z is 30, life is good. There's a couple ways of doing it. Yes, sir? I expect you guys to show my relationships. I know I had them right away. Matter of fact, this is one of my favorite problems on the face of the planet. And I know that's 60, 60, 60, 120, and 30, and 30 right away when I see it. But I want you to have supportive evidence because an easy look left, right, forward, back. I want you to have the setup. Okay? It's about how did you do it as opposed to what's the answer. All right? And it goes quick to do the setup as we step through. But those are the things you're thinking in your head. I want to make sure you put those thoughts on paper in a logical order. And people are like, oh, it's so much work. But if you're wrong, and people are like, there's no way I'd be wrong. I mark these things wrong a lot. Okay, just because someone went during their air math session decided that 50 plus 20 was 80. Okay, so it's something that I'm able to go back to the original work and go, oh, okay, they intended this, so I can give you partial credit. If you don't have anything and yet the answer's wrong, I can't do anything. And on this last test, if you didn't have any supportive work, I didn't give you any credit for the right answer. Okay, didn't happen. Because I don't know how you got it. Lucky guess, great, fantastic. It's not about lucky guess class. I want you to actually show your thought process. Next thing. So now we're on the second part of this. We just went through the idea that we had triangle sum theorem, okay? We are now going to exterior angle of a polygon or remote interiors, okay? And this is triangle exterior angle theorem now. Now, exterior angle of a triangle is an extension of one of the sides, okay? So this is angle 1. The remote interior angles of a triangle, okay, are the two non-adjacent interior angles. They cannot be adjacent to the exterior angle. Okay, now I want to show you something, and I'm going to put in a value to help me talk about it, but I want you guys to put it in your notes. Do you understand that? So right now, that's the stuff I want you to get down. I want you to know that that's where those things come from. And then here's the deal. I want to show you what we're about to do, and I want to show you in such a way that you understand, hopefully, what's happening. First of all, are you all okay with the measure of angle 1 plus the measure of angle 4 now? I put in that 4 so I could refer to it, are 180 degrees. Are you okay with that? Okay, I know that because that's a linear pair. Okay, now, let's do it this way, linear pair. Now, I know what we just went through, that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is 180, because that's triangle sum theorem. They're both 180. I can set them equal to each other. Measure of angle 1 plus the measure of angle 4 equals the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. This is substitution. Are you okay with that? I can totally substitute that in. Okay? I know you guys don't have room for this. I just want you to see what I'm doing on this. But are the steps that I've done thus far, do they make sense? Okay? Now, do you see the measure of angle 4 is in both sides? Let's subtract it. By subtraction property, I know the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Well, that means the exterior angle is equal to the two remote interior angles. Triangle exterior angle theorem. The exterior angle is equal to the two remote interior angles. Crazy! Because that's my exterior angle right there. Okay, now I've got my two remote interiors. Now, keep in mind, you can probably find most of the triangle angle values without this one piece of information. But you won't find it as fast. Okay? This relationship helps you to work through the triangles faster. Why am I concerned with you going faster? Because you have a test, the SAT, that gives you 60 questions and expects you to produce the correct solutions in 60 minutes. And that's it. That's all you got. You may or may not finish. Okay? But you have a better chance of finishing and finishing well if you remember how to do things shorter and quicker. Okay? More efficiently. So as we go through, we're finding the missing measures of the triangles. 65 and x. I know that 124 plus 65, is equal to 65 plus x. So I solve it. Right? And people are like, well, that's like 59, Bloom. You okay with that as I go through? So that's going to be sitting 59. Now, some folks are like, oh, okay, that's fine. But keep in mind, the remote interiors add together to equal the exterior angle. That's what I'm using. It's the triangle exterior angle theorem. The remote interiors, matter of fact, this one's faster than you can imagine. What's 8 plus 1? 9, right? I put an 8 on the end because it's 80 plus 18, it's 98. That's what I've got, and I'm doing 80 plus 18 is equal to the measure of angle 1. By the time you set up 80 plus 18 plus whatever this is to subtract from 180, and then to subtract that from 180 again to find 1, you'd be done. And on to the next problem. Okay, you guys do C. Use the exterior angle theorem relationship. The two remote interiors, the ones that are non-adjacent, add together to be the exterior angle as I extend that side, one side of my polygon. Remember, there's one exterior angle at every vertex, just one, and it's always less than 180. Now at this point, hopefully you're seeing I got 140 equal 5x plus 2x, and that's 7x. So I got 140 equals 7x. Divide by 7 and 20 is equal to x. And they just asked me to find that instead of plugging it back in to find my measures. Okay? How you doing? Tribbiani moment, right? 1, 2, or 3? 4. Yeah, there's 4, right? Okay, 1. Yeah, I know this exterior angle thing exists, but I'm not so sure about what to do with it. 4, move over. I'm going to teach the last 3 ones. Okay, I really won't pull you up, but show them. And let's pretend I'm doing the wave as I walk by. Okay, so if you guys put them up as you put up in front of you so I can just see where we're at. Because I can go over them like 5,000 more times, maybe. Of course, you know, we'd run in time constraints and stuff. Okay, all right, got a lot of really shy 3s. Okay, got a couple 4s that are pretty proud of themselves. All right, loving it, nice job. Here's the deal. Recognition of the application of a shortcut, okay, is a big deal. Okay, it really is. So keep in mind as you're going along here when we do these next ones, these are more involved. And they probably will push you to use the whole triangle sum theorem, which you'll still get the right answer. Recognition on setup with the exterior angle and the remote interior. Like my example here is, this is 81's the exterior angle to 47 and x. Okay, so if you take 81 subtract 47, you'll find x. If you look at 81 and y, you'll be able to do linear pair. And after you do that, you go 58 minus whatever you got, and you get z. So it's up to you, but go ahead. See what you got. You got D, E, and F. They're our last 3. And I want you to use your row partner. And just like any good trivia game at a restaurant, I'm going to start showing the answers in about a minute. Do one at a time. Linear pair. Get that one. Then after you get that, these two make 81. Okay. And these two make y. After you get that, you're golden. Does that help? Okay, give it that a try. See how it works. Excuse me, ladies. Remember, get these turkeys done. Lastly, you know, you gets it? Totally rocking. Oh, you don't know how to do it. Oh, I couldn't come by and explain. You doing okay? No? Okay, that's all right. So here it is. May I? All 3 of these you could add up to 180, but this is hard to solve for. But you can find this one because they're a linear pair, right? This plus this, it's 180. These 2 add together to make 81. 81 minus 47 will give you x. Because the exterior angle and these 2 remote interiors. Are you okay with that? Okay, because that's just the relationship that we're doing. Are you okay that this is 99? Because y plus 81 is 180.
Okay.
X plus 47 is equal to 81 as well, because that's the exterior angle and these are remote interiors. So I subtract 47 to get x. Now I've got a choice. I could use this value and this value, just to double check, because I just found x, so I used that. But this one and this one, this 58 and z, make y, 99. So 99 minus 58 is 41. It's my z. You okay with that?
Sure. Yeah.
That was sarcasm.
No.
Lastly, show me. Show me what you got. I'll be back. Pick on you. It's my job. Okay? People just think I'm just mean. Well, part of it's that. Okay? Yeah, please, Lexi, go ahead and grab a thing there. Grab a pass. Okay, so let's see what we got. Hopefully you saw that 81 plus y is equal to 180, and so y is 99. Okay? Hopefully you saw that x plus 47 is equal to 81, because 81 is the exterior angle with these two remote interiors, and you're able to subtract there, okay, and found that it was what? 35 as we went through on x. 34, yeah, that too. X is 34. And then my last one, z, I know that 47 in x, which we found was 34, 47 in x was 81, but z is sitting out here, and I can go 58 plus 81 plus z is equal to 180, okay, as I'm going through, and I can look at it like that, or I could go, well, 58 plus z is really 34, and that's what I'd get if I subtracted my 81 from my 58 and z coming through with my y. And so I'm not 58. I want 99 there. Sorry about that. So if I'm looking at this, remember y was 99. I got 99 is equal to 58 plus z, and that's where my 34 came from. 99 is my exterior 58 and z, so I'm happy with that. And I'm going to be coming up with 41 coming out at the end is my z value. Okay, so long way to get there. I'm not sure what my deal was. Are you okay with D? Yes or no? Is it feeling all right? In E, I can find that between 68 and 2, 68 plus the measure of angle 2 is equal to 128. Okay, measure of angle 2 must be 60. Okay, I can find that there, 1 and 128 is 180. So this has got to be 52 as we step through. And those are my two values I should be looking for. We okay with those? Any questions, follow-ups at all? My last two, as I'm looking at 32 plus 2, this is angle 2, not 2 degrees. So 32 degrees plus the measure of angle 2 is equal to 118. So I subtract my 32. And 118 minus 32, what is that? 12 gives me a 6. So 30 more. What is that? 76? 86? 86, yeah. 86. Okay, so I'm sitting there, and I'm looking at my next one. If that's the measure of angle 2 is 86, and I'm talking about the idea that if that's 86, 1 and 18, measure of angle 1 plus 118 is equal to 180, and I can take those away and go to the measure of angle 1 is 62. Let's pop that in. Are we okay with those measure findings? Okay. Now, today, it's all about angle sum relationship and exterior angle sum theorem. Remember, it's the exterior angle is equal to the two remote interiors added together. Now, be all to end all? No, but it's kind of like noticing a few different things as you're doing your math to make you more efficient and faster. Okay, so make sure you're comfortable with that. Make sure you know that's what we're doing. Here on campus, we're going to pull out our 3-4 assignment, but you folks at home, have at it, have fun. Go ahead and print off the assignment and get started.